Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I will be explaining of past year's question of test 1, 2011 and 2012. So first of all, the first question, let z be a function of two variables given by z equal to fxy equal to square root of 25 minus x square minus y square over y. So the question asks us to find the domain range, and we need to sketch the domain of the function. So first of all, we need to find the domain, right? So we are given of 25 minus x square minus y square. So we just do like this, make it greater and equal to 0, and then we'll get this x square plus y square less than equal to 25. So the domain will be xy x square plus y square less than equal to 25, and y is not equal to 0. So the range will be real number. So the graph will be of circle. The origin is 0, 0, and the radius is 5, like this. So the second question, sketch the level curve of z equal to square root x square plus y minus 1 square for the value of z equal to 1 and 2. And we need to sketch the graph of the surface. So first of all, we substitute the value of z equal to 1 into the equation. So we will get this equation. We sub the value of 1, x square plus y minus 1 square equal to 1. So when we sub the value of 2, we'll get the value of x square plus y minus 1 square equal to 2 square, just equal to 4. And then when we sketch the circle, it will be just like this. This one with the radius of 1, and the larger circle will be the radius of 2, and it touching the value of negative 1. And then when we sub the value of x equal to 0, and when we will get the value of y minus 1 and negative y plus 1. So y minus 1 will be this one. The gradient will be positive going upward. And then this one, negative y plus 1, will going to downward the negative of gradient. And then we sub the value of y equal to 1. So we will get the equation of z equal to plus minus x. So the graph will be like this. And when we combine all of the graph, we sketch the three dimension of x, y, and z. When we will get the shape of a graph cone, like this one. So the third question is find the del f over del z and del f over del y. If z is a function of x and y, and define implicitly by z square equal to x at z minus z tan xy. So first of all, we write all of the equation into like this. F x y z is equal to this one. We just change z square into the right hand side, and then we find the del f over del x. Just differentiate it to x. We'll get negative z exponent xz plus yz second square xy. And then we find the value of del f over del y. We'll get xz second square xy. And then we find also the value of del f over del z, which be 2z over minus x exponent xz plus tan xy. And then we found the value of dz over dx. It just we do the operation of from what we got the above, negative del f over del x divided by del f over del z, and then we'll get this equation. And then just do the same. We find the del z over del y. using this operation, divide this by this, and we'll get this answer. So question 4, we need to find the rate change of P given by P equal to R square plus RH, where R is increasing at the rate of 0.1 centimeter per second and H is decreasing at the rate of 0.5 centimeter per second when the dimension of R is 10 cm and H is 14 cm, which means height. So first of all, we write the equation given, and then we find the dr and dr over dt and dh over dt. Just given from the question 0.1 and negative 0.5, which means it's decreasing, and then we just differentiate it with respect to r and h, and we'll get the value of 2r plus h and r. So to find the value of del P over del T, we just write this equation, and then when we write it, we just need to substitute from the value of what we got above. When we substitute, we'll get this, and then the value of R and H, we just substitute our value 40, 10 and 14, and then the final answer will be negative 1.6. So the question 5, a cuboid with dimension of 30 cm, 40 cm, and 50 cm was heated and each of the side expanded to 1 over 16 cm. So we need to use the partial derivative to approximate the error in measurement of the total surface area of the cuboid. Basically, we need to find the total area only. So we let 2x, 2y, 2z will be the length, width, and height. So total surface is just add all 2x, 2y, and 2z. So the given value is x equal to 30, y equal to 40, z equal to 50. So dx, dy, dz will be the same value of 1 over 16. So to find the area, we use this kind of solution. We write it back, and we need to differentiate and sub the value of dx, dy, and dz. It's like this. The first one is we differentiate. We remove the 2x here, 2y, and this 2z. And then we will sub the value of all x, y, z, and we'll get the final answer of 30. And the last question is number 6. Determine the local extrema and saddle point of the function fxy equal to 6xy minus 2y cubed plus 2x cubed plus 1. So first of all, we need to find the first derivative of fx and fy. Basically, we just differentiate it respect to x and y. So we will get the value of 6x plus 6y plus 6x squared. And then fy will get 6x minus 6y squared. And then we need to do the simultaneous equation to get the value of y0 and y and x. So just like this, we will get the value of y equal to 0, y equal to negative 1. And then from that, we will get the value of x equal to 0 and x equal to 1. From the value that we got, we can know the critical point of the question 0, 0, and 0, negative 1. So to make it easier, we just make the table like this. The point will be 0, 0, and 1, negative 1. This is wrong. Should be 1. And we need to find the second derivative. So fxx, fyy, and fxy. So the value will be 0, 12, 0, 12, 6, 6. So the type that we got is at the point 0, 0 is saddle point, and at the point 1, -1 will be the local minimum point. So that's all.